Good day, my angels. Sorry I can't be here. I'm at a meeting. I volunteered for a committee, and then they decided to meet during the day. Anyways, you'll have to watch the video. Can you please get out this Chapter 12 practice quiz that I handed out last class? I also emailed it out on the weekend. If you don't have a copy, well, you should have checked your email on the weekend, but you can get a copy from the teacher. I left extra copies. Pause the video while we do that right now, while the rest of you are getting out the take-home quiz. Now, important information. Your test on plate tectonics is next class. That's Friday. That's 2 days from now. We have finished plate tectonics. What will be on there? It's mostly multiple choice and matching. In fact, the written, there's only 3 marks worth of written. I'm even going to tell you what the question is. On the written section, I ask you to give me some of the evidence for continental drift. I think I gave you 5 things. I'm going to ask for 3 or 4 things. But what you're also going to need to be very familiar with for the matching and the multiple choice are some of the diagrams. For example, some of these plate boundary diagrams and what all these things mean. You're going to need to know some information about earthquakes, absolutely. You're going to need to know, what else? The different symbols for the different boundaries, how to read them. You know what? You're going to need to know what we talked about in terms of rift spreading and ocean ridge spreading, and where the older sediment and where the thicker sediment is and where it's thinner. So this is from our section 12.1 notes. This is a different style of a test. You're going to need to know the material in terms of memorization. And then I have given you a vocabulary crossword. I certainly have put some of those on the matching section of your test. Definitely want to have done all the homework. And hopefully I've stalled long enough for you to find your quiz. Here we go, mark your own. I stole this right from the workbook, from the textbook actually, and I'm not wild about every question here. Specifically, number 1 says, what evidence was not used by Alfred Wegener to design his continental drift theory? Well, believe it or not, the answer here is D, because he didn't know about them. But I don't like that question. What I'm going to say is, can you tell me some of the evidence for continental drift? And it would be all of these: the jigsaw puzzle fit of the continents, similar fossils on distant continents, matching rock types or geological formations on opposite sides of the ocean, coal deposits in Antarctica, and the 5th one was evidence of glaciers around the equator where now it's too hot, which means that they were in a different location. So although number 1, D, I'm not wild about it. Which of the following best explains the concept of plate tectonics? Pieces of continents float over liquid mantle. That sounds good. Continents on the lithospheric plates move by convection currents in the ascenosphere. Well, that sounds actually even better. Oh, you know what? What's wrong with this? The mantle. So that's no go. Well, it's liquidy, but it's not that the pieces float, because not just the continents, there's also oceanic plates as well. So that's also what's wrong with that one. Continents on the asthenosphere move across the partly molten lithosphere. Continental plates move by convection currents in the outer core. You know what? These all sound good. Again, I'm not wild about this question. This is what happens when I pick a quiz. The answer key wants me to pick B, but you can cross that question out. I will be clearer on the test. Well, you also have to understand the difference between continental drift, which is the drifting of the continents, and plate tectonics, which explains how the continents drift. Which of the following seismic earthquake waves are measured by seismographs? We have P waves, we have S waves, we have L waves. D. That question is fair game. What's the name given to a line of volcanoes that are not found near a plate boundary? We call them hotspots. Like Hawaii, that's not near a plate boundary. What do we call the volcanoes that are near a plate boundary? Those are usually composite volcanoes, like Mount Baker, like Mount St. Helens, like all the coastal volcanoes that run along the Oregon, Washington, BC coast, because we are right on a plate boundary. Which of the following geological features is associated with the collision of an oceanic plate? Okay, So we have a continental plate and an oceanic plate. Well, what we're talking about there then is plate boundaries. Here's continental, oh, here we go. Continental, oceanic. So here's some of the features that we're talking about here. Not oceanic, not converging or transform, this type right here. So what do we have? We have subducting, we have slab pull. Okay, let's go look at the quiz and see which one we got here. Which of the followings are associated? Earthquakes and volcanoes? Mountains and volcanoes? Well, mountains form of volcanoes. So, yep, you know what? I'm already looking at D, because earthquakes and mountains. D, all of the above. What type of plate boundary occurs where two oceanic plates collide? So the fact that they're colliding means it's a converging boundary. This would be a converging plate boundary. In what layer do the convection currents that move continents occur? Not in the inner core, not on the outer core, and not in the crust, because the crust is solid. I think earlier I said that the mantle was solid, and that was wrong. The mantle is a thick sludge. This is where the action occurs. Which type of seismic earthquake waves travel through the outer core? I should make this bigger so you guys can see everything. Click. Which type of seismic earthquake waves travel through the outer core? This is a bit obscure again. It's P waves because the P waves go through anything. The S waves gets blocked and the L waves travel along the surface. What name is given to a diverging boundary under the ocean? So this is what we called a spreading rift. Sorry, totally circled that. We call it a ridge, actually. I apologize. This is the Mid-Atlantic Ridge. Where is a shield volcano most likely to occur? A shield volcano most likely to occur. Well, in a mountain range, these are usually the composite ones. At a spreading ridge, these were the rift volcanoes. So no, under a subduction zone, no, you know what, over a hot spot. In fact, these are the places like Hawaii. Match the term on the left. Okay. I like this. You know what? I think every one of these words shows up in your matching section on your test. So what's the difference between focus and epicenter? The epicenter is directly above where an earthquake actually begins. C. The focus is the point inside the earth where an earthquake actually begins. G. What's a lithospheric plate? The lithosphere is the outer layer. It includes the crust and the upper part of the mantle. F. You know what? I can go cross that out. A subduction zone. What the heck is a subduction zone? Sub, think like submarine. This is where you have one plate that's really, really heavy, and another plate as it bumps in is getting forced underneath like that. So this plate is moving this way, this plate is moving this way, and then this is slowly melting back into magma. We called this, because we said its weight now starts to pull it forward, and then way back there would be either an oceanic ridge pushing it that way, or something like that. So, D, the result of one plate diving beneath another plate. That's a subduction zone. (15) Mantle convection. Is that an area where, no, B, where two plates are forced apart. No, that would be a diverging boundary. Nope. You know what? It's flowing currents of material that help move plates across Earth's surface. This was mantle convection was, I think I had it in the notes. Let me see if I included it. I think I did. I think I had a little. This is mantle convection, where you have hot molten magma bubbling up, and forcing things apart right there. And here, things will be getting forced together. As the magma cools, it sinks back down. Oh, spreading ridge. First of all, that was E. Spreading ridge. That's going to be, oh, I crossed out B. That's a point where plates are forced apart. I shouldn't have crossed out B. That was silly of me. What's an area where molten rock rises to the Earth's surface? A volcano. There's 3 different types. Make sure you know the 3 types of volcano. We didn't include F. Short answers. Why does ocean rock increase with age the greater the distance away from an ocean spreading ridge? So, how would we say that? Let's write it out, Mr. Well, new magma rises at the ridge, forcing older rock away. Which means the further you go from a ridge, the older the rock. The closer you go to an oceanic ridge, the newer the rock. B. Explain how magnetic stripes in the rocks provide evidence for plate tectonics. Since the magnetic stripes reverse periodically, let's see, how do I want to say this? Since the magnetic stripes reverse periodically and symmetrically, in other words, on either side of the ridge, it suggests that there has been constant expansion. Let's see if I can go like this. Constant. Oh, don't want to do that, Mr. Dueck. Couple more. Use the following. So there's definitely going to be diagrams like this, and they're going to be black and white, but they'll be pretty clear. Slab pull right there. Convection right here. Ridge push right there. The description is kind of like what the names sound like. So what's the description of convection? Let's see. Hot magma rises and gets forced outwards. When it does that, then it cools as it sinks. Slab pull. How would I answer, or how would I say that one? This pulls down, so how would we say that? Descending portion of the plate. Descending portion of the plate pulls the rest with it, or pulls the rest of the plate with it. So not only are we getting forced here, we're getting tugged down there as well. And this is where the Earth will get remelted and essentially recycled back in the Great Circle of Life, Simba, the Great Circle of Life. B, ridge push. B, ridge push. Material rising right here from the hot Earth, pushes new material away. Compare and contrast the following: the ground motion of a P wave and an S wave. So I would say this: P wave, same direction as the motion, it's back and forth. S wave equals side to side motion, perpendicular, if you wanted to say that. So same direction as the same direction as the, how would I say this? Same direction as the earthquake wave. Remember the spring that we did, okay? Remember the spring that we did. And S wave is the side-to-side motion. It's perpendicular to the way the wave travels. Composite volcano with a rift eruption. So composite equals more violent. Think Mount St. Helens. Large amount of lava and ash. Rift eruption. Think like under the water, for example, in the ocean. It forms ridges in the ocean, or it forms on rifts. It forms in ridges in the ocean, or it forms in rifts in the land. Milder, is that word? Mild eruption. Large amounts of lava, but not much ash. Okay. Where else? We could say composite also, comma, forms on subduction boundaries. What's that? Forms right here, because right here the earth is cracking and allowing magma to come squeaking through right there, forming volcanoes. And when the pressure builds, it can really explode. Rift eruptions, those form either at ridges in the ocean or on rifts in the land. Okay? I'm not going to collect this quiz, so if you didn't do it, well, you missed out on a chance to learn from your mistakes. But you do want to study, and that's part of your homework. Now what you want to do is keep this quiz. Also on Friday, day of the test, you want to hand in the plate tectonics vocabulary crossword. And if you haven't handed in these yet, hand them in. You can hand them in today. If you want them to study from, you can hand them in Friday. Could you also please get out? We started the next unit on biomes. If you were away, you can see the teacher and get a copy of the biomes notes. We'll pause the video right now until you get your copies. All right. We paused the video. We're back. So what were we talking about here? We were talking about breaking the earth up into its constituent systems, or into its constituent parts, biomes, as it were. So here we go. They're the largest division of the biosphere. If you were away, you can get this from online. I'm going to go really fast. We talked about biotic, living, and abiotic components. The two biggest abiotic components we said that affect biomes are temperature and precipitation. Temperature and precipitation, because they both affect what kind of plants can grow. They affect how long the growing season is. You know what? As soon as you start affecting the plants, you're going to start to affect what animals can live there. We looked at the different biomes, and I'm going to give you a sheet today to color. That's going to be part of your homework. We said that based on a graph like this on the table, you can figure out what biome we're talking about if I tell you the annual average temperature, if I tell you the annual average precipitation. If you find where they cross, you can figure out what biome you're most likely a part of. These are the biomes of the world. I'm going to be giving you a black and white version of this, and you guys today part of your homework is going to be to color with pencil crayons your own version of this, because I can't photocopy a color picture. We talked about latitude, we talked about elevation, and if you would be so kind as to turn to ocean currents. I'm going to finish off the lesson, and then your homework is going to be to study for the test, to color the biomes handout that the teacher is going to give you in a little bit, and I also have some more questions to work through as well. So how do ocean currents, an abiotic factor, affect biomes? Well, coastal areas like us are generally warmer, wetter. We have mild, wet winters. We have fairly mild, wettish summers. The ocean is a moderating influence. In the summertime, the ocean absorbs heat. That's why when it's really hot, if you go for a walk on the seawall, you'll notice right by the ocean, it's noticeably cooler in Vancouver. So it absorbs heat in the summer. Oh, and it warms cold air in the winter. That's part of why we don't get a lot of snow here in the lower mainland in the Fraser Valley. When do we get snow? When we have one of those Arctic blasts that's coming from the north and the east, not from the ocean, but from the interior. Then it gets cold. But if we're getting our wind coming over the ocean, brings us warm air, damp air. In fact, we call it the Pineapple Express in the wintertime when we get those really warm, rainy days. Here's a map of the ocean currents of the world. You don't need to know this. You might need to know how to read it if I gave it to you and asked you questions about it. What were the two most important abiotic factors affecting the formation of biomes? You may recall. They were, that's right, temperature and precipitation. Well, if you combine these two, you get what we call climate. Climate is the combination of temperature and precipitation. And one of the things you're going to have to be able to read is a climatograph, which looks terrifying. They're not too bad at all. Turn the page. What's climate? Climate is the average pattern of weather conditions that occur in a region, observed and recorded over a period of years. And we can show it with what's called a climatograph. So here is a climatograph in your notes. This is a graph of general climate for a specific region. They are obtained over 30 years, which helps to smooth out any unusual winters or summers or springs. And they have average, well, what? Monthly temperature versus total monthly precipitation. Oh, temperature and precipitation, Mr. Dueck. You said those were the most important abiotic factors. Yes, Captain Obvious, I did. So here's a graph. So here's what it's saying. The bars are the months. January, February, March, April. These are the months. Now, the temperature is the dotted line. The bar graph is the precipitation. So this particular climate had a rainy winter, little less rain, little less rain. Summer's fairly dry. Winter's pretty rainy. Oh, and average temperature. Now that's on this axis. Looks like in December it's a little bit above 0 degrees. Looks like in July the average temperature is about, 18 or so. 19, below 20. Okay. What's the average temperature in April? Oh, average temperature. Got to go this way. 10 degrees. Average rainfall in April would be about 100 and, what do you think that is? 120 millimeters, 115 millimeters. Gets drier, gets wetter, gets hotter. Notice, though, there's not that big a difference between the average cold and the average hot. This does not have huge temperature swings. although there's a pretty big difference in the rainfall. Now we're starting to talk about climate. Describe the following climate. Okay, how would I describe this? Well, I notice here's temperature, and here they've gone by degrees, so I can be fairly accurate. You know what? It doesn't get below freezing, because this is 1 degree, 2 degree. It doesn't get below freezing in the winter on average. So I would certainly say this. It's not the prairies. Oh, and not only that, wait a minute, Mr. Dueck. It gets hottest in, let's see. Oh, I got to read this properly. Oh, Mr. Dueck, did you read this properly? You know what? I read the wrong graph. The average rainfall, this is the average rainfall. I was reading that as temperature. The average rainfall is the blue bar graph, Mr. Dueck. That's why it's important to read these properly. And yeah, I screwed up. I wish I'd done that on purpose, but I didn't. I just messed up. Let's try that again. Average temperature is this line here. Average temperature is this line here. So here's what I notice. When is it hottest? Here and here. What months? It's hottest in January or February. So first of all, is this in the northern hemisphere or the southern hemisphere? Yeah, if you have summertime in January, we can circle southern hemisphere. And I notice dry summer, wet winter. How wet? I need to know what 100 millimeters of rain is really, really like. How far north or south, I wrote. Well, let's see. How cold does it get in the wintertime? In the wintertime, the average temperature, the coldest it gets is 12 degrees, which is still pretty warm. It definitely doesn't get below freezing, not even close. So I would say this is probably southern hemisphere, but still close to the equator, probably in the tropics. I'll put here tropics, I think. Also doesn't get all that hot. The average temperature when it's hot, 22, 12. What about rainfall? Well, they didn't ask us about rainfall. And usually I can figure out where we are from temperature better, because I know the further north, if you go to the North Pole, it's colder. If you go to the South Pole, it's colder. Close to the equator, it's warmer. Oh, and I know in the southern hemisphere, their winter is our summer and vice versa. So that would be an idea of some of the questions I can ask from a climatograph. I looked this up from online. This is the climatograph of Cape Town. Cape Town, Mr. Dueck? Cape Town, South Africa. I stole it from, I think, a United Nations page. So were we right? Is it southern hemisphere? Yep. Is it close to the, well, it's the southern part of Alaska, which isn't that close to the equator. Alaska, Africa, which isn't that close to the equator, but still close-ish. I need to see a map. Certainly we were right about the southern hemisphere. Southern hemisphere. What's your homework? This, not yet. We'll do that another class. Part of your homework is going to be color biome sheet. I have pencil crayons on a cart. You can borrow those as long as you return them, or you can color this at home if you want to do it really nice. This is a sheet you're going to be allowed to bring into the test. This is a sheet you're going to have to bring into the test. Oh, and by the way, please, for the plate tectonics test, don't forget your purple sheet that has all the transform boundary, all the plate boundaries, all the plates, all the continental plates on it. And study for test. Mr. Dueck, what's the biome sheet? What the heck is this thing here? So you're going to get a blank biome sheet like this. And it's going to be your job, pick a color for the boreal forest, look where that is in your textbook, and color the areas that are the boreal forest. Pick a color for the desert, probably brown. Probably for the forest, some kind of green. Grassland, maybe a lighter green. Well, you know what? You got lots of different, because there's temperate deciduous forest and temperate forest. There's only so many greens to go around. Tropical rainforest. Usually it's traditional to go purple for tundra, brown for desert, white for ice, which is kind of tough to show on white paper, but that's okay. And what you're going to use then is this sheet here from your textbook. From your textbook, it's page right there, page 10. Okay, page 10. So, what are you working on? Page 13, numbers 1 to 4. Page 15, reading check questions 1 to 5. You can do them on the same piece of paper. Color the biome sheet, study for test.